It's so blurry, dude.
Yeah, it was so blur. We're just going to make up words now. Welcome. This is the Salt Lake City Python Meetup group. If you're looking for the PHP Meetup group, that is not here. You are in the wrong place. I'm Ferris. I started this Meetup group 4 years ago now. We had our 4-year anniversary in January. That was a lot of fun. Who went to that party? That was a lot of fun. So yeah, we have a shindig to celebrate that every year. That one has beer and pizza, not just pizza. So, yeah. So this Salt Lake City Python, it started when I was in Sugar House Coffee, and I noticed a gentleman named Ken and a gentleman named Joe were working on a Django project, and we started talking, why isn't there a Python meetup group in Salt Lake City? And we Googled it, and there was one, but it was like in Draper, and who wants to drive to Draper in the middle of rush hour? See, no hands this time. So we started Salt Lake City Python in Sugar House at a company I used to work for called Zaniac. And slowly we evolved and we changed locations a couple times. And now I'm not at Zaniac anymore. I'm at Team. I work with Dylan. Yeah, so that's a lot of fun. So yeah, now we're here. We got this space. Actually, where's Martin? There's Martin. Martin's our speaker, but he's also like the captain of the space. I don't know. He doesn't have a spacesuit, but he does get to be the liaison to make sure that we have an awesome University of Utah space, which is just amazing. But there are other meetup groups. We have Utah Python, which is kind of the umbrella group. So all the money that you donate tonight or that we gather from sponsors, that's all listed on the Salt Lake City Python page. And we have an open accounting, and it'll show you all of like our ins and outs so that you can see all the stuff, and we file taxes and all that other fun stuff. And if other meetups need some cash, or they need sponsors, or they need prizes, we can send that to them. But the main resource that we send to them is knowledge and venues, and people send to them, say, hey, Python Utah North, you guys need a speaker? Boom, there's a speaker. Now, this gentleman over here who's ecstatically waving his hand is also my father. He is the leader of the Python Utah North up there. Say hi.
Hi.
He goes by Louie or Dad. I think only one person in the room can call him Dad, so... Anywho, that's that. So that's Python Utah North right there. There's their website. Here's our website. We also have the Salt Lake City Pie Ladies. That is a group that is amazing. That is led by Carrie Fisher. I want to say Carrie Joy or Carrie Fisher. Anybody know offhand? Joy, yes. Why was I thinking Fisher? Oh, because that's the... See, I'm terrible with names. That's the real reason I asked for people to put name tags on. So yeah, that's them. If you or someone you know is interested in learning Python, the Pie Ladies are a really great place to start. They also have some of the best documentation about beginner Python on the web. So if you ever Google around for that, you'll get it. Same with the Django girls. They have the best documentation to learn Django, hands down. Like, it's amazing. By the end of that one, you can code up, what was their particular project? Isn't the polling one, it is some kind of like Reddit equivalent or something. It's a lot more complicated. It gets really in-depth, but it's also really high level, like, hey, this is how you install Python on your computer. So one of my favorite guides on the web. We also have Python at the Point, South Valley. Anybody from there tonight? No? Oh, we got one. You guys are not at Needle, you're at the other place now. You are at...
Oh wait, I don't think I heard exactly what you said. I just thought you meant, are you from South? I'm from like Utah.
Ah, okay. I thought you were from that group. We do have a group that is close on the border of Utah County. They are in Draper. They used to meet at Needle. They don't meet at Needle anymore. They meet somewhere else. I can't remember the name of it.
Canopy.
Sorry?
It's called Canopy. It's
Canopy.
AMX building.
Yeah. Okay. So that's where they meet now. Provo is now part of Python at the Point. Girl Develop It, SLC. Anybody Girl Develop It represent? No? I kind of represent. I did one workshop for them. They're also a really cool Salt Lake City a group to teach women, get them into engineering, get them into coding. Yeah, it's fun. There's a lot of cool ones in Salt Lake City. We got websites. This is now a running joke. I think after the 4th time it becomes a running joke, right, Dylan?
I think 3.
3? Is it the 3rd time?
Hat trick.
Yeah. I lost the server. Like, I just can't find it. It's not that we can't afford, I just can't figure out which server this is hosted on, and I keep trying to get to it, but I can't. But UtahPython's hosted on GitHub pages, so that one isn't going away anytime soon. But it is done in Angular, so don't tell any of the Python people, okay? So that one's completely static. If you want to make a contribution, though, and help me fix it, we have GitHub accounts right here. This is our organization GitHub, so if you give a presentation, we will fork it onto our organizational GitHub, and that's like one go-to spot where you can find all of the code and presentations people have given. Sweet. Let's talk about our sponsors for a second, because without them, we wouldn't have delicious pie pizza. So, first off, Pythonistas like you. Thank you. Do you guys remember those PBS ads? No? Anyway, pat yourself on the back. We also have XMission. Matt White's from XMission. Do you want to give the spiel, or should I? I know I do it better, don't I? XMission. They won't throttle your internet. Well, unless you're like, no, they won't. It's XMission will promise you net neutrality. They are one of the best service providers. Utah's first internet service provider? Yes, that's right. So if you were in Utah in the 90s, you probably remember the dulcet tones of a modem dialing up into Salt Lake City to get your internet. That would be XMission. Matt works there. They're amazing for co-location, and they've been sponsoring the Meetup since May, yeah, for a while now, and they've sponsored everything. Pizza, raffle prizes, like these Raspberry Pis that we have, these Python books that we purchased from our members who wrote them, but they're still sponsored. So if you or somebody you know wants to sponsor, definitely hit us up. We got other sponsors. We have the University of Utah. They're a venue sponsor, obviously. It's a really great spot. Anybody have trouble with parking today? Everybody figure it out? That's the only hiccup I have with this particular spot, is that it's a university, so you have to pay a small fee for parking. For that, I apologize. But on the bright side, this is a really great space. And Tech Systems. Hi. You want to give a spiel about Tech Systems?
Sure. Is everybody here familiar with Tech Systems, or?
No.
Okay,
So
Tech Systems is the nation's leading IT staffing and IT services company. So when I say services, we do more than just staffing. We have a whole global services unit as well. Helps to make us nation's leading. In Salt Lake City, we do everything from essentially like Logan to Provo. We've got about 80, 90 clients across the Wasatch Front, and work on pretty much every technical skill set. And we really pride ourselves on being more than just headhunters, but really being a true resource to the community. So.
can I add on to your spiel a little?
Please.
So Tech Systems was our original sponsor back in 2014. When we first started, they were consistently sponsoring us, and yeah, now we have other sponsors too, but Tech Systems coming back on, so that's awesome. What was the other thing? Oh, Tech Systems first recruited me at my previous gig, and one thing I really liked about them versus all the other recruiters is nobody from Tech Systems asked me if I could code an iOS project for them, because I don't know how to do that. Tech Systems actually understands the technology. The recruiters are very knowledgeable, surprisingly knowledgeable for, well, it shouldn't be surprising, but it is surprising compared to other tech recruiters. They actually know who they're trying to recruit. They actually know how to match talent to demand. So that's what I really like about Tech Systems. So if you're looking for a gig, well, you got a couple places. Tonight we'll give you a quick chance to market yourself, but you can also talk to Kate over here, and she'd love to grab your info. Am I right?
Absolutely.
Sweet. And sweet. Yeah, so new sponsors always appreciated. Just message us over the Meetup. All of our expenses are logged right here at this URL. If you're wondering where this URL is, I just realized I haven't published it. Sorry about that. I will copy it onto the Meetup during the talk. And while that's going on, you can actually edit into this. If I'm not mistaken, the URL will look just like a past Meetup URL, only it'll say March instead of... Oh, you did? Matt, thank you. So yeah, that's posted. You can edit this as you want. And we will revert your changes if you just write swear words. Yeah. So something I like to do along with our intros is try to get to know everybody, but we used to go through and introduce every single one of these, everybody, and it was just as boring as a graduation when they read out all the names. So we decided if you're new, you get to introduce yourself. So who's new? Nice. Then we have a few. And another thing I want people to think about is code is awesome, but code isn't the thing, it's the thing that gets you the thing. So I like to try to ask one non-coding question right here. So your name, your occupation, and your favorite spring activity, because it's March. Can you believe it's already March? It's crazy, right? So I'm Ferris. I'm the senior backend janitor at Team. Team is trying to build the workplace of the future. And my favorite spring activity is probably walking in the rain or mud. And cherry blossoms are nice too. I have a bit of that side to me, but they're nice. And photography. So, who else is new? You get to introduce yourself, William,
All right, want me to stand up?
if you want.
See me? And William. I'm a chemist right now. And my favorite spring activity is, I love going to southern Utah and hiking at this time, either in spring or the fall. It's the best.
Pick somebody else who has their hand up, William.
I'll go. I'm Sam. I'm a computer science master's student at BYU, and I like to play lacrosse in spring.
Nice.
Okay.
This gentleman in the back.
My name is Ron Haycock. Martin invited me to come tonight. I know absolutely nothing about coding, and I'm grateful. Martin's been trying to teach me to go just like this. I'm a management accountant. I specialize in helping new businesses get started, and we teach you how to own nothing and control everything. We help you so that if you own anything, if you get sued, you never get it taken from you. So you absolutely, if you don't own it, they can't take it. But you make the money by controlling it. So you own nothing but control everything. That's our specialty is in internal and external structure. Thanks, Martin, for inviting me. Seems like a fairly decent group. I'll have to get used to their sense of humor.
Ron, what's your favorite spring activity?
Actually, at this time of year, I'm a high school and college sports official.
Oh, fun.
And I officiate baseball and women's fast pitch softball. I used to officiate basketball, but I blew out my knee in 2011, so I just got that replaced a year ago.
Cool. That is a fun activity. Who's next?
I'm Jacob. I'm a chemical engineer. I work for a company in North Salt Lake called APCO. We model, optimize, and automate chemical processes. And my favorite spring activity is soccer and frisbee, because that's when the snow melts.
Go for it.
My name is Jason Woodland. I was invited by Kate Conroe, the recruiter. I specialize in life insurance, and I'm a crypto asset investor. So I'm excited to see what you guys present this evening. As far as spring goes, sunshine and blue skies. Just like to hang out in the sun.
That's fair. I love that. Anybody else? This gentleman.
My name is Garrett Robbins. Occupation. Yeah, no idea. My favorite thing to do in spring is dye Easter eggs. Yeah. That's what I do. I trade crypto, so I've been trading for a while and just thought I'd come and see what you guys talk about. So.
Sweet.
My name's Zach. Kind of left my last job currently to kind of focus on some things with my buddy Tyson right here, trading crypto, other business ventures. But yeah, my favorite spring activity would probably be anything outdoors, like motocross. Probably my favorite sport. So.
Sweet.
Yeah, I'm Tyson. I currently have a couple just sales LLCs that I run right now. I travel on the weekends and sell tax liens right now. But yeah, I got into cryptocurrencies and lost a ton of money on masternodes, so that's why I'm here. And yeah, I'm just trying to get way familiar with the space. So
sweet. This is gonna be very technical talk, right?
Yeah.
No? Yes? Yeah, that's what, yeah. I've noticed, I've been to one other Bitcoin meetup, and it was more about the asset trading and the finance, fiduciary aspect, which is interesting, but I like the tech stuff.
Yeah, for sure.
Who else? Who else is new? This gentleman, Ben.
I'm Ben. I'm mostly systems administrator, but also, do some coding, also trade some crypto, so kind of into everything that's going on here. First time at one of these meetups, was invited by Martin, so I'm interested to see what's going on. Favorite spring activity? I love it when the pools open up, so I can go swim in the water again.
That is nice. And who else is up? This John.
Yeah, my name's David. I'm a PhD candidate at the School of Computing at the University of Utah, and I like to jog.
Yogging. Who else?
My name is Tanner. I am a money and health insurance producer and crypto investor, and kind of entrepreneur. So business and things like that, that's what I'm interested in. So.
Who else? Going once? Going twice? Okay. I want to take a quick poll. Who is here because they're just interested in Bitcoin more than Python? Or just, that's why they're here. They heard Bitcoin. They're like, oh yeah, let's go to that. Okay, and who's here because they're interested in Python? Well, guess what? By the end, you're going to be raising your hand at both. That's what I'm thinking. Because Python is the second best language at everything. That's what it's known for. Yeah, well, I guess so. I mean, my friend built a robot, but that's a whole other thing. No, Python is the language that you use to sketch something out, and when you want to get serious with it, you might switch to another language unless, you're doing a software web startup, and then you keep wondering why you're still on Python, but that's a whole other thing, right, Dylan? No, Python's really good for sketching things out and learning computational concepts. So that's why I'm a huge fan of the Python and the community. Sorry?
Then you're like, I can push this to prod.
Yeah, and then you do, and you accidentally make money, and then you have to stick to it. But, speaking of money, let's look at who's hiring in the community. So this is the section where you kind of get to market yourself, or if you're looking for a job, you can take a look at all these awesome people. Team is hiring a software developer. We're also hiring QA people, so if you're not as technically minded, but you still know how to click around and break things, then Team is a great place to work. Team is trying to build the workplace of the future, everything from booking meeting rooms to doing things like meeting requests or figuring out how to best build out and utilize spaces, which is Dylan's expertise.
What, breaking things?
Yeah.
Yeah, breaking things. And then RentWorks is Logan. I don't know. Did you post that?
No, it was posted last month. I don't know if they're still looking or not.
Okay. We might have some carryover. Okay. These are ones that we know from last month.
It's not. It's no
New
longer.
month? Okay. I'll just delete both of these. Domo, I think they're still looking for their senior tech consultant. I'm not sure.
Yeah, they are.
Yeah, and VirtueStream, anybody know that one? Going once, going twice. Okay, well. Anybody know of any other places in the Valley that are hiring any technical position? Doesn't have to be Python.
I have tons.
Check with tech systems.
Do you capitalize the S or no? I'm trying to remember. The S stays lowercase, okay.
Yeah.
Anybody interested in non-technical positions?
Ron for non-tech. I'm going to write Ron for non-tech right here.
And Ron, this is a shared board, so if you want to put your contact information on it, just link to it and type in.
Or just have Martin do it.
Yeah.
Anybody else? Know of any positions around the Valley? Oh.
There's my employer's looking for a Scrum.
What's your employer's name?
Connection Point. It's spelled with an X rather than a CT. If you're looking it up online.
Sorry, I pressed the wrong button there.
No, you're good.
Connection with an X?
Yeah, instead of the CT.
Like that?
No, the middle one. Yeah, those.
Sweet.
And I think it might be lead scrum, so.
I'm typing this with like a 1 second delay of the screen on its screen this big over here, so I can stream this. Anybody else? Okay. And this is the fun part. If you're looking, go ahead and introduce and market yourself. And I will misspell your name on this lovely sheet over here. Anybody looking?
There you go. I'm looking.
Louis Shabib. Who's this
I've been looking
guy?
for the last, what, 5 months?
Somebody hire him, please. He keeps.
You won't get out of my house.
So that's generally it.
Okay. He has the whole thing.
Mm-hmm.
Been in the biz for a while.
Yeah.
Anybody else looking?
Data science, looking for data science stuff. His name is Yannick.
William.
William, yeah, I'm looking for bioinformatics. Yeah.
There's a few in Utah for
Yeah,
that.
there are. So just trying to find a way in the door. So changing careers. So
Sweet. Is Kale Fisher here?
I was cold called recently, but ARUP has some stuff.
yeah.
Yeah, I work there, so.
Oh, okay.
In the genomics group.
And then, it's Kale Fisher, right? The other one who, he went to last February and then he's been coming consistently. This is the first time he's not here. I think it's BioFire?
Yeah, BioFire is one.
No, it's Ubota.
Ubiota.
Ubiota, that's the one.
And then, what's the other one?
IMC,
Health Catalyst is hiring.
Yeah, ancestry.
There's a few.
Uh-huh.
You're probably just covered in offers right now, right?
Oh, yeah.
Yeah, okay. Anybody else looking? Going once? Going twice? Oh.
Well, U-Star Genetics is hiring bioinformaticians.
Oh, U-Star
Genetics.
Genetics. You should start writing this stuff down.
I haven't heard that one, but.
Okay.
Oh, that's the state granting agency, isn't it?
Yeah.
Yeah, okay.
Cool.
Have you tried Myriad?
Yeah, I've talked to some people there, so I have some connections in there.
Mm-hmm.
They're not hiring one yet, but.
Sweet. Any community news from the Python world? Usually I just copy the Python newsletter, but I didn't have a chance today, so.
Yep, there's an article today, top 10 languages and skills you should know. Python's number 2, just below Java.
Java or JavaScript?
Java.
Oh, well.
Pure Java.
Then that's a
JavaScript's
clickbait
on the
article
list
if it's
lower
not
down.
number 1. Come on.
Several flavors of Java are on that list. JavaScript.
Anybody else know of any Python news? Like in the community? I have one. It's going to be the thing that everybody's probably sick of hearing about. Uh-oh, net neutrality again. So, who took a chance to donate to the EFF last year? Anybody? Yeah, a few of you, right? They give you this sweet hoodie if you donate enough. Oh yeah, glows in the dark, says lovely things. I'm going to keep pushing for the EFF because they are definitely looking out for your best interest if you're in the tech community. Another thing that I did yesterday, and I usually do this, is I call my congressman or my senator, but this time I called my state rep, and I was asking I was thinking I was just going to get like some secretary, and I was calling to ask them what their opinion about sponsoring a net neutrality state level bill would be like, right? Because that's kind of been the approach. And you know what happened? I called, and I was so close to hearing about like, oh, okay, we're going to have like some secretary is just going to take my name and info, and then she's just going to put it in like a system. And so I called and I got, this is Representative Steve, and I was like, what? This is awesome. I'm actually talking to Steve Eliason, my state representative. So turns out they actually will pick up a lot of the time if you call your local rep. Now is a really good time. Utah legislation is still in session. So I would encourage everybody to take 10 minutes tomorrow on your lunch break, just call them, ask them what they think about sponsoring a state-level net neutrality bill. Because even if they completely shut you down on the idea, you still get that idea in their head. And they know that at least one of their constituents is concerned about this. So that's what I want. That's everybody's homework. Okay? Usually I don't get too political, but when it comes to net neutrality, that's something that I have to put my foot down on, because that is something that is the reason we have so many startups in Utah. And if you need more information about what the heck net neutrality is, just grab anybody in this room and they can probably tell you. Yeah, it was a really fun phone call, actually. He picked up and he's like, "You're a constituent. Oh, wait, is this about the Donald J. Trump highway? I'm not voting for that, okay?" That was how he literally picked up the phone. I'm not even kidding. I'm like, it's not, but thank you. It was a really fun conversation. No matter what side of the aisle you're on, actually, I'm very surprised that state reps are very responsive to their constituents. So yeah, that's enough for that community news. Anybody have some new topics they want covered? Bitcoin, for example, was a topic that somebody suggested a couple of months ago, and now we have Martin, who's here to give a talk about it. So if you have a topic in mind, we have a few that a lot of people could give a talk on. Anything that reaches out to somebody and they're like, "Oh, that looks awesome." Like OpenCV, that's cool. Anybody know what OpenCV is? It's basically take some Python and attach it to some images, and now Python can tell you what that image is. So it's like, "Oh, that's a cat." And so you're like, "No, Python, that was a dog. I need to teach you better." But it's pretty interesting stuff. We got application packaging, all kinds of things. If you want to give a talk, just message us on Meetup, and we'll pick it up, and we'll put that all together. One more point of order that I don't have on here. Oops. As I said, tiny screen. Okay, so April, when is that? Our next meetup is the 4th, okay. Has anybody ever been interested in trying to MC one of these things? Dylan? Anybody else has been interested in trying to lead a meetup, especially if you've been to this Python meetup a few times? If you have, talk to me. I'm going to be in Japan for the next one, so I actually won't be here. So somebody else can lead the next meetup and make fun of me the whole time, and I won't even know. So
except it'll be on the stream.
Yeah, I'll stream it, but it'll be like 2 a.m. there or something. Sweet. So if anybody else wants to organize, let me know. We're going to take a 3-minute break for our speaker to get set up. Feel free to grab some water, more pizza. I think there's a little bit left. And yeah, I will see you in 3 minutes. spiel. Shall we get started? So a lot of you, so there's a lot of people here who are interested in finance. There's a lot of people who are interested in Python. Bitcoin is kind of one of the coolest things ever because it's one of the first times that we are able to make something digital but not copyable. And Martin's probably going to correct me on all of the technical stuff with that. But it's kind of amazing.
I wasn't paying attention to what?
No, he wasn't paying attention, so he's not going to correct me. But yeah, Bitcoin's pretty awesome. Martin came, when did you suggest this? 2 months ago?
It was, I think it was at the soiree or whatever shindig that we have for the anniversary.
Oh yeah, so at our soiree, Martin came up and he's like, hey, let me do a thing about Bitcoin for your next meetup. And I said, yeah, let's do that. That sounds great. So here we are. Martin, you're a gentle welcome.
Cool. So I'll just start with a couple disclaimers, just because. So I've been interested in Bitcoin for maybe a couple of years, but I actually decided to go very deep into the tech a few months ago. So I hope I don't mislead anyone on the stuff that I'm going to talk about. But if I do, and if you think there's something else that's more correct, just correct me. It doesn't matter. And we're going to skip a lot of things just because the more you learn about Bitcoin, the more you realize that there's so much more to learn, and it's insane how much stuff there is to actually be able to learn. The third one is very important because I really suck at presenting, so I'm going to try to... is that what you're talking about, that the screen goes off? Okay.
I'll fix it for you.
Yeah. So just be patient. And to those that thought that this might be like a talk about price and markets and stuff like that, I'm not gonna say anything to that regard just because it's not that type of talk. But if you're interested, a couple of students and I are kind of partaking in a venture that involves some of that and a little bit of Python and automating trading stuff. So if you're actually interested in that kind of stuff, we can talk about it later. So, had to start with a joke, and that's a crypto joke, which is kind of weird, but it's kind of cool. How can you tell the difference between a good cryptography joke and a random string of words? You can't. They're indistinguishable. And it's supposed to be funny, but it's not. But there's a lot of cryptography involved, and there's just a lot of mumbo jumbo.
The delivery, Martin.
What was that?
The jokes are all in the delivery.
I said I suck at presenting, didn't I? Okay, so this is kind of what we're going to talk about. We're going to talk a little bit of math, and I'm sure there's people that are more knowledgeable about this stuff than me just because I'm not a math major. But we just have to go through it just to learn how private keys, public keys, and all that kind of stuff actually works. How we represent a public key, how that public key is used to create it and make it into a Bitcoin address, and then ECDSA signatures, which is kind of the foundation of Bitcoin in a way. And also HTTPS, I mean SSL. It's ECDSA is used for all kinds of signatures over the web. So relevant, even more relevant. And Bitcoin smart contracts. So yeah, there is smart contracts in Bitcoin. So maybe that will get some people excited about Bitcoin a little bit more. And also script is the language that Bitcoin uses for these so-called smart contracts that are just a little bit, they're a lot more simple than regular Ethereum and whatever other platform smart contracts, but we'll talk about it a little bit more. And the last, I guess transactions, what do they consist of and what do they look like? We'll go through that. And also the demo is going to be kind of all of this taken into a little bit of Python code that I'd be willing to share afterwards. There's a lot more in the Python code that we're going to see just because, again, there's just a lot more going on, but we're going to just use a simpler version of that code. Anyways, so Bitcoin basics. It's a decentralized peer-to-peer network, which is what the main protocol in Bitcoin actually uses as its foundation. It's a distributed public ledger. Everyone hears about the blockchain buzzword, so we all love that. Consensus rules is just kind of what the network agrees on, how transactions are validated, how do you issue the currency, the 21 million coin limit, stuff like that. And the mechanism for reaching that consensus, the proof of work algorithm that actually makes everything work and is just one of the most interesting things about Bitcoin that glues everything together in a way. UTXO based versus accounts based. We're going to talk about it a little bit more. It's the whole point is you have something happened in the past that you refer as an input to your current transaction, rather than having an account that says, hey, you have a total of $500. It's more of like you have a whole bunch of different transactions that you've received. So we're going to use those different transactions from the past and use them for your new transactions. Okay, some about the math. So a lot of this is going to be just a bunch of definitions that I'm going to go through, but we're not going to prove anything just because I don't know if we're capable of doing that. So SLCP256K1 is the curve that was defined it wasn't defined for Bitcoin, but it's used in Bitcoin. It was actually defined and created by NIST, the National Institute of Science and Technology. And so elliptic curves look like something like that equation. This is the equation that's used for the curve in Bitcoin. The general equation is y squared equals x cubed plus ax. A is just some parameter plus b, and here a is 0, b is 7, and there's a lot of modulo arithmetic in Bitcoin and elliptic curves in general. The curve right here, this is what it looks like. This is what it looks like graphed over the real numbers, and the bottom one is what it looks like when it's over a bunch of huge prime numbers. So you can't really tell what this is, but technically it kind of is this, and that's how it's defined. It's symmetrical over the x-axis, just because y squared. When you calculate the solution of that, you have a plus minus square root, so that's why it's symmetrical. So there's this thing called finite fields, and it's basically a set of numbers. I don't know if there's point to going into more than that, but it's just a set of numbers that we have from 0 to p minus 1, and it's a finite field prime order. The prime order is the actual prime number that defines that set of numbers, so we have 0 up to that prime number. And that prime number is very, very, very huge. Another thing that's defined from the SLCP256K1 curve is the generator point that's used for all private keys, and that kind of it's basically used for all private keys to be generated. It's just a defined point on this curve, and again, it's just some really huge number that everyone knows and everyone uses. N is another number that's defined by NIST for this specific curve, and that's how many points you have in this group in the finite field. And the group here is defined by how many times can you multiply by g in order to get to 0 again. So the idea is when you have prime numbers from 0 to 7, for example, that means your group is 0 to 6, so every time you do modular arithmetic and you do mod 7, you're always going to end up with a number between 0 and 6. And in this case, it will be 0 and n. And n is just another very, very huge number, but it's actually very close to the prime number here. So elliptic curves use a lot of kind of invented math. So we're going to kind of look at a little bit about how points are doubled and added and multiplied. I guess multiplication uses addition and doubling repeatedly. And the idea is, I'll get to a couple slides later and we'll talk about it. Why this was used is basically because we can hope that the discrete logarithm problem is going to protect people from figuring out what our private keys are. Just because all those numbers that we're going to use to calculate our public key, which is going to be some secret times this generator point. This secret is going to be a huge random number. it's easy to go from the huge random number times g to the result, which is p, but it's very hard to do a log of that same equation in order to go back to the private key, which is s, or we will call it s for now. Questions? No? Okay, so this is what point addition looks like on this elliptic curve. So you take P and Q, which are just some random points. When you add those, you get R, but the actual intersection is the reverse of that, because you okay. Anyways, I don't think it matters that much to go in depth in what this represents. But at the same time, when you have two different points, when x is not equal, the x's are not equal, you just get an intersection on another place of the curve, and that's the important piece here, just because that's how you have to do this many more times in order to get to your public key, which is, again, s times g. Point doubling is when you have the 2 points are the exact same. You only have, again, just 1/3, I guess 1 second and 1/3 point that crosses the line crosses the curve. And that's when you have the points equal each other, it's just a tangent line on the curve, and you don't have any other places that it crosses except just that number that you're going to use later. This is technically negative r, so we're going to be using r for our public key, but we'll go through that a little bit later. So point multiplication kind of takes both of those things together. So if you have 3g, you have 2g plus another g, so 2g is the point doubling that you do. So this is just a bunch of math that has to be done. And then you do plus g when you just add your result 2g plus another g. So most points on the curve that we use that can be calculated on Bitcoin are in this group that we talked about, kind of like that limited set of prime numbers that are defined by the SLCP256K1 curve. And how the public key gets created, as I mentioned, is s times g, and s is just your actual private key. So s is just some huge prime number, and it's very important for it to be random. There are some specifications you have to look up in order to make sure that you get the very good random number generator in order to make sure you don't have collision and stuff like that.
Can I ask that question?
Yeah.
Okay, I know what you were talking about until now. So I totally missed. Could you just remind me what G is?
G is a generator point.
Because now I understand how these things fit around on the curve. But,
Yeah.
Yeah.
So G is the generator point, which is used.
It's a single point.
It's one point on the curve that everyone knows. So for every single private key that gets created, you're going to use that G. So S is the thing that no one else has to know, or no one else should know. Yeah.
Question?
Yeah.
So is G any point on there? Like
It's
is G
just
different
one. It's one defined point.
One
And that,
defined
yeah.
point for every key, I guess, public key, or
No, it's every single key basically shares that point.
Okay.
So that's known for the entire everyone that uses Bitcoin or ECDSA and all that elliptic curve cryptography. Basically, they know this point, and they're using this specific curve SLCP256K1. G is just one point, and everyone knows that point.
Awesome.
Thank you. Yeah. So G is the important thing here that is your actual private key. So again, you double and add until you get to the result. I'm not sure why I included this, but this was just something that the binary arithmetic that I saw is how every single bit, so your key is a 256-bit number, and every single bit, it has to be gone through, and every single bit is doubled, and then each one is also added. I'm not gonna lie, it sounds super complicated, and I did not take the time to look into it. If you have questions, I'd love to actually learn it and summarize it for you afterwards. But just seeing this sentence kind of like blows your mind a little bit. N over S, it has to be greater than S, and S has to be greater than 0. So this is just like a simple check that you have to make sure that your private key basically has to fit in that range from 0 to the size of the whole group of the finite field. So that's what n represented previously. So that means that basically you have about 2 to the 256 private keys available to be created. And just to kind of associate this with something more, I guess, real, is the number of atoms in the universe is estimated to be 10 to the 80th, and this number is approximately 10 to the 77th. So there is a shitload of keys. Yeah. So once we, any questions about the previous? So that was basically how you get your public key, and that's how you can start with your private key. You have a public key that you're gonna use for going forward. Any questions about that? Okay. So there's two different representations for your public key, a compressed and an uncompressed version. And SEC is just a format, standards for efficient cryptography. So your public key is basically two 256-bit numbers, just because you have X and Y. And the uncompressed version of it is you put an 04 as a marker that specifies you're using the uncompressed version of the SEC format, and then your X coordinate and Y coordinate. So that's 520 bits, but we can make that a lot smaller by using a compressed format, because if we know X, for example, we can calculate Y. So we can basically get rid of Y as long as we know what side of the curve it was on. So if it was a positive number or if it was a negative number. And that's how we can basically save half of the space that we need to represent a public key. So you put a 0.2 in front of the X coordinate if it's a positive Y, and a 0.3 if it's a negative Y. And again, the positive and negative thing is just because we take the square root when we're solving this equation. Questions? Okay, so now that we have the SEC formatted key, that's not our Bitcoin address. So the Bitcoin address is going to take a little bit more manipulation, and for that we're going to use SHA-256. And then, so we're going to take the SHA-256 of the compressed or uncompressed SEC formatted key, and then we're going to take RIPE-MD 160 of it, just because that saves us a little bit more space, just because this is 20 bytes instead of 64. And this is done just to basically add protection to your public key. Also, once we do that, we're going to prepend it with another marker that actually specifies what we're going to encode in base 58, which is it's an encoding mechanism that's used for a lot of things in Bitcoin. So you need to be able to differentiate what you're encoding. So, for example, for a regular Bitcoin address, you put 00. If it's a private key, you put 80. And if it's a testnet address that we're going to see a little bit later on, you put in 6F. After you add the marker in front of the RIPE-MD 160 key, you take the first 4 bytes of double SHA-256, and double SHA-256 is just taking SHA-256 of the RIPE-MD 160 hash, prepended with the version of what you're actually going to be encoding, and SHA-256 once on that, and then SHA-256 again on that. You take the 4 bytes of that final SHA-256, and that's going to be your checksum to make sure that nothing has been actually. So that's just a simpler way to verify that your public key and all the previous hashes have been correct. And then that's going to be encoded in base 58, and base 58 is basically base 64 without a few characters. So you don't have 0, capital O, uppercase I, and L, and I think there was some signs that were missing as well. That's why it's base 58 instead of base 64, because you don't have all of them. So they're just like kind of the steps in a little more programmatic way of how you calculate your Bitcoin address. You start with your public key, S times G. And again, S has to be your random secret, so that's your private key. That public key, you compress it, or you use a compressor or an uncompressed version of it. And after that, you take the RIPE MD160 of the SHA-256 of that public key in whatever SEC version you use. And then you prepend that versioning marker before you encode it in base 58, when 6F again is for testnet. And then you take the checksum just to verify, just to have something to verify that your address is correct. And then you base 58 encode that your address with the checksum at the end. And here's a little bit of Python. So you think of some secret. This is definitely not a secure private key because it's very short and it's not secure at all. You take that number and you multiply it by G, which is again that generator point, and you have your address. This sender point here is actually another object that's doing all this work that we talked about for you. I got this code from a seminar that I attended by Jimmy Song, who's he's a core developer for Bitcoin. He's contributed and is doing a lot of great things in the space. So he kind of helped us build our libraries and also gave us a whole bunch of backbone code. Anyway, so this is your actual public key for testnet. So you can't use this on the regular Bitcoin network because you are not going to do anything with it. But we'll talk about it a little bit more later. And then signatures. So ECDSA, elliptic curve, digital signature algorithm. These are pretty much the same thing that kind of what your browser does behind the scenes. And again, there's its main purpose of a signature is authentication, which is it's a way to verify who's the actual owner of the private key and who's authorized the expenditure of your Bitcoins. Non-repudiation, after you've signed your transaction, you basically can't deny that you've done it. So that's what the second point means. And integrity, and it's unaltered, as most of us probably know, when you take a hash of one thing, you know what the result is. Even if you make a slight, tiny little change in your input, you're gonna end up with a completely different hash. So part of the signature. Signing a message, you can sign a lot of different things. You can sign, for the most part, you want to sign your transaction, but there's different variations if you want to sign all the inputs that you have in your transaction, or if you want to sign all your outputs, or a combination of those two things. And again, you're using your private key to sign it, just so you can verify that you're the actual owner of those keys, of those Bitcoins. And yeah, anyone can verify the signature that you've given based on the owner's public key and the message that was used. So this is just the pseudocode for signing. You take the hash of what has to be signed, so in our case a transaction, which is Z. Then P is your public key, which is, again, as we saw before, your secret times your generator point. So your secret is your secret. You can't tell it to anyone else. Tell anyone else about your secret. K is just a new random temporary secret that you're going to use for the signature. And then you're going to calculate a new temporary public point based on this new K that you created. And you're going to take the X coordinate of that point, because you have X and Y coordinates again because of multiplying by the generator point. So that's one part of your signature. The next part is just basically calculating this S value, which is the hash of the message plus R times the secret. And this is, again, this is the owner of the private key that knows the secret, so that's why he or she can calculate this S value. And R, as we said, is just the X coordinate of the temporary public point. And we divide that by K, which is the new temporary secret. And again, lots of modular arithmetic. And this is the pseudo algorithm of verifying that that's correct. This is very high level, obviously, but it's kind of like the gist of it. Again, the verifier is given, and this is not working. The verifier is given what has been signed, so the hash of the message, meaning a transaction, the owner's public key, and the R and S values. U and V are just ways of calculating basically how Z and R are related to S, and U times G plus V times P, you can substitute U and V, and then you come up with another, basically a third public point based on those calculations that you've done, and you take that public point's x-coordinate, and you make sure that that x-coordinate is equal to the R from the previous x-coordinate of the temporary secret, and if those two things are equal, then that's a valid signature, and the owner is who or he or she says they are. Questions? Yeah.
How is K chosen?
It's just another random number.
And then do you know it's not? I guess when you get an S or a K, how do you know if it's? It has to be unused previously. Or
What do you mean?
it's randomly chosen. Is it? It's not defined by the curve. It can be any random chosen integer essentially.
Yeah. Yeah. Wait, you said it's not related to the curve?
Is it limited to?
It is limited to the curve because you're multiplying by that generator point. So you want that point to be
vector value as well.
Yeah, so you want that point to be on the curve again, just because by defining it k times g, g is obviously going to be on the curve, so you want that number to also be on the curve.
Okay.
Okay, dir serialization. This is how you serialize the signature. So the R and S values, distinguish encoding rules, whatever. P2 PKH script sig. So this is what the signature looks like in an actual Bitcoin transaction. It's just split up, but we'll see an actual transaction. And P2 PKH is just one type of transaction. And it's the most common transaction in Bitcoin even right now, although that's changing with SegWit, another topic. So the 49 is just basically how long this R value is, the signature is, sorry. And then you have just different markers. I have to look at my cheat sheet what every single marker is. So yeah, so the first 30 is basically, this is a dirt type signature format. Then you have the length of for the rest of the signature, marker for your R value, which is 0.2. And then the 21 is the length of the R value in bytes. And then you have the actual R value. Then this 0.2 in the middle, again, is just another marker, so you know that your R value has ended and you're going to start your S value. And then the 21 is the length of the S value and the actual S value. Then the bottom part is your actual public key. Sorry, yeah. So it's your actual public key. Again, it's in compressed format just because it has a 0.3 in front of it, and then you have this is your x-coordinate basically AE up to the end, and the 21 is just it's 21 bytes. So Bitcoin transactions. Bitcoin transactions basically have four major things: the version of what kind of transaction it is, the inputs, outputs, and lock time at the end, which we're not going to talk about too much, but it's just basically if you want a transaction to be spent at a future time or at a future block height, you can just specify that in the lock time. And as I said in the beginning, unspent transaction output, this is basically what you use to create new transactions, and you use the unspent transaction outputs as inputs for your new transactions. The input consists of previous transaction hash, so like I said before, you're referring to a previous transaction that's happened in the past, and you're going to use that transaction's outputs as your current transaction's inputs. Vout is just an index because you can have multiple outputs in a previous transaction, so you want to specify which output, because one output could be for 0.5 Bitcoin, another output could be for 0.1, etc. So that's how you specify which output exactly you want to use. Sequence number is not important. Script sig is what we saw before that with actual signature. Output has the amount and the script pub key. And we're going to talk about it a little bit later with what the actual script pub key is. And how fees are calculated, what you pay the miners, is basically the sum of inputs minus the sum of outputs. So that's very important. You have to make sure that you don't leave way too many inputs, way too many Bitcoins left as change when you subtract your outputs from your inputs, just because you don't want to overpay the miner, but at the same time you also don't want to pay too little of a fee because your transaction may not get mined at all, so it may get stuck in limbo for a while. And that's what the sequence is actually used for. You can create a new transaction with a new fee basically, but it doesn't matter. And yeah, the receiver plus your change is the actual outputs, and the receiver is who you're sending the Bitcoins to, and the change is, again, if I give you a $10 bill, but I'm actually trying to pay you $5, you're gonna pay me $5 back, so that's what the change is, and it's just the same concept of basically not overpaying and sending everything to someone else. Inputs are looked up on the blockchain, and specifically in the UTXO set. The UTXO set is the entire set of unspent outputs, and basically your wallet looks up that for you. So even though your wallet says you have 0.5 Bitcoins, it actually might have a gazillion outputs that it's accumulated for you, just because it knows what private keys are in that wallet. And that's how it calculates it based on the UTXO set. So the transaction has to make sure that outputs have not been spent. So the outputs that are used for your inputs, you have to make sure that they haven't been spent, because if they have been, you obviously can't use them anymore. And your inputs have to be greater than or equal to your outputs. And that's again so you don't have, you're not a freeloader and not paying any fees. And the script sig is valid, so all the fluid nodes that are all the Bitcoin clients that are running out there have to verify that the signature for some transaction is valid, or that whole transaction is invalid. And I kind of said yeah, Bitcoin that was received as a UTXO that with the wallet detected. And again, just your wallet has your private keys in it. For example, you have 5 private keys, and then it looks up what prior outputs are referring to those private keys. Private keys is public keys, and that's what your wallet kind of does for you, and that's just an abstraction. The wallet is just an abstraction. It's more of like a keychain, and I think I prefer that concept a little bit better, just because there's nothing really wallet-y about it, just an easier way for us to understand it. But, questions? Okay. This is what a transaction looks like, and we're going to create that. It's just a whole bunch of, it kind of goes back to the cryptography joke. It's just a bunch of random characters. So the first part, 0, 1, 0, 0, 0. That's the version of the transaction. 0, 1 is how many inputs are in that transaction. 2076 up to the 6C is the hash of the transaction that you're referring to from the past. So this is what you're using. So this is a transaction that you're using for your inputs, and that transaction has some some outputs, and you're using that transaction's outputs as your inputs. 0, 0, 0 is just the index of the previous transaction's outputs. So if you have 3 outputs in the previous transaction, this is where you're going to specify if you want to use the zero, the first, the second, or the third output. The next part, so 6C up to 83, that's the script sig that we kind of briefly mentioned. So that's just a variable length. There could be a lot of signatures here. If you have only one previous input for a transaction, you're going to have only one signature. And there's a lot of things that are being done to make this smaller and actually even kind of eliminate this piece of the whole transaction. next one is the sequence number that I mentioned. All the F's. The sequence number, which is depending on what you set it, you can have it set that a new transaction cannot replace the current transaction. So it's been mainly used for RBF, which is replaced by fee. And if you set it to a different value with an E as the second, yeah, I don't remember what the exact number was, it doesn't matter. But like if you set it to one value, you can replace the current transaction with a new transaction with a higher fee for the miner. For example, if this transaction's fee for the miner is way too low, so your transaction is stuck and it's not getting verified, and you've specified that you allow new transactions to be replaced with a higher fee, this is where you would set that. 02 on the left right there specifies how many outputs this transaction has, and it should have at least 2 as a minimum. Well, not necessarily, unless you're spending all the inputs. Because as I said previously, your outputs are one output for the person you're sending bitcoins to, and then the change address, which is your own address because you're returning the change to yourself. Then the next number is A0 up to all the zeros. This is actual value of, so this is the amount that you're sending to the person that you're sending to, which starts at 1976 up to AC. This is the script pub key. So this is how you're locking the bitcoins that you're trying to use to the person that you're trying to send it to. Again, you have another value, and the next script pub key, which is basically your change address that you're going to send back to yourself, just because you don't want to send everything to the person that you're sending to. Script. So this is the language that Bitcoin uses, and this is how you create smart contracts in Bitcoin. And yes, Bitcoin does have smart contracts, so that should probably make it more exciting, I guess. I don't know. It's Turing complete, and it's intentionally made to be Turing complete. You don't want to have loops just so that you don't have to deal with the whole bunch of random shit that Ethereum has to deal with every once in a while. All the hacks, all the smart contracts spending way too much money, stuff like that is just a way to kind of protect the network with a simplified version of a scripting language. It's stack-based scripting language, last in, first out. So you just stack up all the functions that you want to run, and then you just pop them out of the stack. We'll see that in a second. And again, yeah, it's a simplicity, serves as a security base, no infinite loops, etc. Has some basic conditional logic. It doesn't have loops. You have if, else, not if, blah, blah, blah. Another thing you can use, or I guess the actual elements and functions in script are, the elements are the numbers, the signature for a transaction, the public key, and the functions are what they're called opcodes. And an opcode is basically defined by a certain value. And in the hash 160 case, this is taking the SHA-256 of your public key and then taking RIPE-MD 160 of the SHA-256. So that's what the first op hash 160 means. Op add, if you want to add values. Op equal, make sure that some values are equal. Op check sig and verify a signature, yada yada. So this is what it kind of does as a stack language. So your script at the top, 2, 3, add, 5, equal, that's the actual script that's used to define this whatever calculation. And you start from the left and you execute to the right. So we start at 2, we push that value onto the stack. Then we go to 3, push that value. So 2 and 3 are on top of each other. Then we go to add. So add basically takes the 2 elements that that are before it's called. It pops them out, calculates it, and then it pushes the result back onto the stack. Then we add another 5, and we have 2 5s on top of each other, and then we make sure those 2 values are equal. Again, equal just takes the 2 values that are preceding it and make sure that those are equal. If they're equal, you end up with a true, which is what you want to do. If it's a false, then this script was invalid. Okay, P2PKH. Again, as I said, this is the most common transaction in Bitcoin, and it stands for payment to public key hash. And it's public key hash because at first there was just P2PK, which was pay to public key, but that's not enough security, and let's just say it's just not enough security because you're taking the actual public key and you're paying, and you're creating a transaction based on that public key. And in this case, you're basically creating a Bitcoin address, is what we call a Bitcoin address, taking the SHA-256 and then the RIPE-MD and then a double SHA and etc. So that's why there's an H at the end, the hash of the public key. Payment to Bob's Bitcoin address, output is locked to a public key hash. So again, this is how you define who gets to spend the Bitcoin that you're sending. That output is locked to the public key hash in the transaction that you're sending. The script pub key is the locking script from the previous transaction. So you're locking the amount you want to send based on the public key that you're sending to, and it's called a locking script because you need an unlocking script later on, which is a signature to spend that public key. So yeah, conditions how to spend output, contains Bitcoin address, public key, that's where it gets its name, and it looks like this. So the script pub key, and script comes from the name of the Bitcoin scripting language, script, and that looks like op duplicate, op hash 160, public key hash, op equal verify, and op check sig. And then script sig is what you use to unlock the Bitcoins that you locked with the locking script pub key. And that solves the puzzle. Signature pub key that unlock output. Okay, there's a video that we can watch, but I don't think we want to. It's basically this, but in a video. I don't know. This is just easier to go through and quicker. So you just put the script sig in front of, oh, I didn't add what the script sig consists of. Anyways, you put the script sig in front of the script pub key, and then you evaluate that with the script language, and you push things onto the stack. So sig and pub key are your locking script. So you have the signature and the public key. You take the signature, you take the public key after that, you add them on top of each other. You duplicate the public key, you take the hash 160 of the top public key, and you get a public key hash. I mean, okay, that's kind of how you go through it. I don't know if you do you want me to go through it in detail? You
Sure.
can kind of see it.
Yeah, finish.
Okay. Okay, so yeah, you duplicate the two public keys, you take the hash 160, and you get the public key hash. Then you take another public key hash that was in the locking script, and you push it onto the stack again. You do equal verify, which verifies that the public key hashes match, because the first public key hash, so the lower one, is from the unlocking script, and then the top one is from the locking one. Equal verify, you make sure those match. If they match, then you're good to go. You push a 1 onto the stack, which kind of disappears because you have other stuff going on, other things to check. And check sig basically takes the public key and the signature, and it verifies that signature and the public key match. That signature was actually signed by the public key, or the private key, which matches the public key. And now we get to see a little bit of code. Any questions? It's tiring. Actually, that's the line here. That's gonna suck. Okay, this looks terrible. Okay, can we see that? So again, as I mentioned, there's just a whole bunch of code that was written kind of for us before the seminar, and we utilized that to create our own transactions. So the ECC is just elliptic curve cryptography, where we get the generator point, and the generator point is just another object that's defined as the X and Y coordinates that we talked about before that. You calculate the secret, and we kind of saw this as a snippet on one of the slides. It's not a very good sender. Private key, you calculate the sender's public point, and we can just print those, and we do the same thing for the receiver. So this is the sender's public key, the actual Bitcoin address, and then the receiver's Bitcoin address. Okay. So this is where we create all the transaction cool stuff.
Are these, this is all in the testnet?
Yeah. Okay, so we start with the private key of the sender, and again, we're just referencing the same secret that we created up here. The target address is the address that we want to send to, which is this guy right here that we calculated, just some random thing. The target amount, so how much we want to send to that person, is 0.049 bitcoins, which is actually a lot of money right now. So we're just on testnet, so don't worry. Change address is my address that I'm going to send the change back to. So that's the sender's Bitcoin address. Make sure I don't oversend. And this is how much I'm going to send to myself. And the difference, so I should maybe go back a little bit. So initially the private key that I created and the Bitcoin address that derived from that was basically this address. I used a faucet, what's called a faucet in Bitcoin, where you get testnet Bitcoins that you can use for testnet transactions and test new features and whatnot, whatever. And that one had 0.65 Bitcoins in it. So the change amount is 0.6 and the target amount is 0.049. That's how much we want to send to this this guy. Fees, that doesn't matter right now. Previous transaction, so this is what we talked about before, what the previous transaction that I'm actually going to use. The previous transaction's outputs that I'm going to use as inputs for my current transaction. And this is a transaction that I got from the faucet when I got the 0.65 Bitcoins. So transaction inputs, again, the hash of the previous transaction, which output I want to use. So I want to use the 0th index, and the sequence, doesn't matter, transaction output, whatever. So the target hash 160 is derived from the target address that we calculated up here. And I just saved it right here in the target address variable. Where was I? Okay, so yeah, we decode that address using this function that was again pre-written. Just we can go through it, but there's way too many functions in here to go through that. So we append the transaction output to the outputs. So we're going to do this twice because we want to have the amount that we're sending to someone and then the change that we're going to send back to ourselves. So we have the two transaction outputs. And again, we have the amount that we want to send, the target amount, and that's times by 100 million, just because of the 100 million Bitcoins. We put what the script hash looks like, which is the public key hash, which is the target hash 160. Whatever, we do the same thing with the change address, which is my address, so sending back to me the change. Create a transaction object, hash type, sig hash all, is what I mentioned briefly, that you can have your signature basically sign either all the inputs or all the inputs and all the outputs in your transaction, or just a variation of that, just one input and one output, or one input and all the outputs, or whatever. So this basically, sig hash all basically says sign all inputs and all outputs. Take a transaction signatures hash for the index 0, just because we have just one one signature, because we're sending to only one person. We're assigning the transaction and encoding it in dir format. Again, this is just a bunch of magic that's happening behind the scenes. We're going to sign which is basically signing a transaction that we talked about with the private key and encoding it in dir format. We're going to add sig hash all at the end of that dir formatted signature, just because we're specifying, yes, the signature is for all inputs and all outputs in this transaction, so don't look for another signature or other outputs or inputs, basically. It's a binary version of it, and this is how we create the yeah, we just get to serialize the actual transaction in that weird, crazy bunch of zeros and ones, or a bunch of zeros, a bunch of numbers and characters that we saw. So a lot of magic behind the scenes, but I think that would be just way too much to talk about. So this is a block explorer that we can just parse the transaction that we created just to see it with a little bit more things that are gonna be a little bit more descriptive. Again, it tells you what the addresses are in this transaction, so the sender and the receiver, what the fees end up being for this transaction, the transaction's hash, then the inputs for this transaction, which is the address that we're sending to. This is my address actually. This is the sender's address. How much this person has to spend basically. The previous transaction is where this amount was gotten. The previous hash is the hash of the previous transaction. That basically was the faucet transaction. This is the script that we saw previously in the slides, what kind of script type it is. Then we have the outputs, who we're sending to. This is the receiver. Pay to key hash. This is my address that I'm returning the change back to. And that's about it. This is the size. This is the most average size of an actual Bitcoin transaction. This is usually how big they are. And now we get to broadcast this transaction on testnet. Or not. Shit. What was that? Oh, successfully broadcast. But I did not get a transaction hash of that. So I can't look that up. But I guess I can look up the addresses and see if there's anything sent to them. Send. So this is the faucet. This is the previous transaction that I made. Oh, I totally botched this because initially the address that I got my bitcoins from the faucet had 0.65, and I sent to this new address 0.049 and sent 0.6 back to myself, and I left 0.001 for the miners as a fee, and I just didn't do this again for the new transaction. So basically this address doesn't actually have that much, so that's why the transaction failed. But yeah, about 2 hours ago, whatever. And I think that's about it. So yeah, if you guys are looking to learn more or use any of this, I'm willing to share it all, or any other resources. These are kind of the references I used, some books and the seminar that I went to, YouTube, and yeah, so that's it. Sweet. Thanks, Martin.
Anybody have some questions?
Yeah.
I have one question at the beginning. You were generating your private key.
Uh-huh.
And what's to assure that your private key, of all the billions,
it's more than
enough
billions.
to win the lottery and hit somebody else's?
It's just the size of how many private keys are out there. It's impossible almost to have collision just because there's so many of them. I mean, there is probably a slight probability, but at the same time, it's very.
It's like snowflakes.
What was that?
It's like snowflakes. All snowflakes are different.
Yeah.
Supposedly, just because there's so many possibilities.
Yeah, and if you pick one snowflake and it has some certain type of sequence, you're going to take another one that's going to have a slightly different one. And that's why you kind of want to have a good random number generator that doesn't have any patterns or any sequences in it, just so you actually don't end up with the same private key that you calculated in the past or something like that.
So every transaction has its own private key?
No, every Bitcoin user has their own private key. The transaction consists of other things, yeah. Yeah. Yeah.
Professionally, personally, emotionally, whatever. What's your goal for you personally in learning and teaching all this?
Well, first of all, my goal is to learn it. So that's why I decided maybe I'd try to teach it, just so I can share even the limited knowledge that I have. My end goal? I don't know. I just want to be part of this new type of space and economy that's been created. And if maybe you were one of the first people that was there, the fin surfers, whoever, in the beginning of the internet, I mean, you kind of got to see some of the most explosive technology in the world happen. And that's how I view Bitcoin and the things that are happening around it. Because this is just such a tiny fraction of what Bitcoin consists of, and all the new things that are being developed on a daily basis and all the companies that are working on it. And just that whole concept of decentralization, open source, everyone can do whatever the hell they want. I just believe in that so much. So that's why I think that learning how to do this is going to help me in the future, because I believe that that's how our economy is going to become and what it's going to be. Just because we're not going to have to rely on anyone else, and that's the point of Bitcoin. Just that financial sovereignty and not having the middleman and all that kind of shit.
Which I totally agree. I just didn't know if you were looking to do a startup. Like,
yeah.
When I say Bitcoin, I really mean crypto. I don't know if you mean crypto by saying Bitcoin, or if you're like, yeah, I just love Bitcoin.
Kind of. I mean, they're kind of used interchangeably, but they're not the same thing, of course. Bitcoin is kind of like where it all started and where a lot of things are happening even behind the scenes, not kind of like where you have all the other crazy shit coins that have a bunch of marketing and all that kind of stuff. That's one thing I don't like about the space. And there's just, again, we live in a world that's just full of media and news, and I don't know, that's why I decided to stick with Bitcoin. Because at first I actually thought that Ethereum is maybe the best thing that's happened in the world, but then I was, maybe I should just look up.
There's so much crap around it.
Yeah, I just want to look up a little bit, where did even Ethereum started? Because I mean, even Vitalik Buterin was a huge part of Bitcoin. He's written a lot of libraries. Even one of the best Python libraries for Bitcoin is written. He's not maintaining it anymore. From I don't remember since when, but he wrote it. So I mean, like, he started somewhere as well. Eventually, having a business to actually maybe apply all of this in a more general way for the average people and average businesses, I think that'd be great. I've been pondering ideas all the time, but at the same time, I still want to learn exactly all the applications that it has, which is probably impossible, but at least I want to try to learn as much as I can. Yeah,
So,
sorry, no, you think you...
No, I was just saying, out of all the startups I've gone to and talked to people, you were by far the most educated I've heard.
And that's the problem. Because I've been doing this for like 3-4 months now, and just because I attended the seminar, it cost me some money. It doesn't matter. I met some great people and I learned a shit ton. And then I also started reading books, reading articles, listening to people knowledgeable about it. And I think that's the right way to learn, is just throwing blockchain here and there and decentralize this and decentralize that. I mean, like, if you go look at CoinMarketCap and see how many things are actually not even mineable, which is the core of this technology, I think that's just ridiculous.
So what does it mean for a coin not to be mineable?
So it's pre-mined. So you basically have a database, and then you assign your coins to a bunch of people, rather than people having to earn through mining new coins. Because I mean, that's the point of mining, right? You create new coins and you verify transactions that everything has happened. Well, the full nodes are actually validating the transactions, but the miners are. That's their main purpose, to create new Bitcoins. And in order for them to create new Bitcoins, they have to prove that they've done some work, and that's what the name is, proof of work. They spent some energy, they spent some man hours, they spent a whole bunch of stuff, and that's what mining is in a very, very small nutshell, or I guess very, very good one. Does that kind of answer your question?
Yeah,
maybe
just,
because
I'm having trouble understanding why you would have a coin that you don't mine then.
Yeah, exactly. Like this is the question that most people don't ask. Like, everyone says that they have a new coin and they just write the ERC20 standard that everyone uses for Ethereum. It's literally just, I don't remember how many, like 10 or 15 functions you can write. Like, I think it's great that you can just create new tokens like that and distribute it into the world. But then you also have people that actually create their own tokens, and they assign a bunch to the owners and a bunch to other. And they say, oh, we're going to get to the moon with this coin, so you guys should invest in us. And then we get to keep all the fucking money. And yeah, so that's the big thing about crypto right now. I think there's just so much scam going on, and I mean, it's just that's what happens, I guess. Just experimenting in a different way.
Just sell essential oil with it, and then
Yeah.
Paris, do I have a deal for you?
Yeah, you had a question.
Blockchain essential oils.
Yeah.
Let's all start.
No, I actually had just a question on, I'm not sure if you're familiar with MetaMask and like some of their faucets, but I have some money stuck on a Covan faucet, which is like the testnet for MetaMask, which is like the browser.
So, why does MetaMask sound so familiar?
It's for Ethereum.
Yeah, it's for Ethereum. It's like a browser wallet.
Oh yeah. Okay, yeah. MetaMask is it's like a Chrome extension.
Yeah, it's a
Okay,
Chrome extension.
yeah.
And I was just wondering if you're familiar with it at all, because for some reason we were trying to figure it out. We can't figure it out, or if anyone else is. But there's a test network that's on there also that I somehow have money in there, and I don't know how it got in there. I can't get it out. I don't know how to get it out. I don't know how. We have no. The only way that the money could have gotten in there is if someone accidentally transferred it to my wallet. So I'm assuming that's how it got in there, but we just can't get it out. So I was wondering if you're familiar.
I'd be happy to look into it. Like, I haven't played with Ethereum too much.
Yeah, it's not that much, but it's cool.
I can help you.
Yeah.
I can give you the address to send them.
I could try and help you.
Cool. Awesome. Yeah,
if you want
appreciate
to.
it.
Yeah. Any other questions? Yeah.
So I've seen a lot of headlines about how as the blockchain gets larger and larger, it seems like it's becoming less sustainable since all these transactions are based on all of the previous transactions. So can you speak to that a little bit in terms of like what it looks like in the future, like all the computing power needed to continue to do this?
Yeah. So have you heard of Bitcoin Cash?
I have, yeah.
Do you know why it came to fruition?
They forked it, but I didn't
They
get
are
Bitcoin. I'm just kidding.
Yeah.
They are Bitcoin.
So Bitcoin Cash, what they did, and I'm not way into Bitcoin Cash or at all, and it's kind of like a maybe very biased view, but to your point, they made the blocks very large all of a sudden, because instead of trying to solve it in a better way, in a more secure way, with working on things like creating smaller signatures, creating smaller addresses, having one signature instead of 5 when you have multi-sig transactions, and all that kind of stuff, they decided to make the block size bigger, and so they can fit a lot more transactions in it, which actually makes that problem even escalate to a huge number, just because you have a 1 megabyte block in Bitcoin and you can fit as many transactions. And I mean, you kind of want it to be competitive for miners, for people that are using it. You want to create a little bit of an economy around it. In Bitcoin Cash, they were just like, yeah, this has to be free and this has to be instantaneous, but no one's really using them because they approached it maybe in the wrong way, because they're trying to say, yeah, we are Bitcoin. Even though the people behind it are very prominent Bitcoin people. But they're trying to make a whole bunch of money just because they have a faster network, so you should use our network, because our Bitcoin Cash network actually transfers coins a lot faster. But because our blocks are so much bigger, we can put a lot of transactions, but no one's using Bitcoin Cash for the most part. We can look at the mempool right now and see that there's maybe a couple hundred transactions being made, and Bitcoin has like tens of thousands. I don't know how many there are right now, but it doesn't matter. So Bitcoin Cash, you get to basically double the size of the block. That's their main idea, or make the block size bigger over time as it fills up. That's a problem, because even right now with the 1 megabyte block that we have in Bitcoin, the entire blockchain is about 170, 180 gigs maybe. And if you keep doubling and doubling and doubling over time, that's going to be impossible to sustain for smaller people. Because right now I can go buy a solid state drive for $50 that has like 256 gigs or something like that. And it's easy for me to keep doing that as long as it progresses at the same rate. And it's going to progress at the same rate just because you get blocks every 10 minutes. If you don't get blocks every 10 minutes, if it's less or if it's more than 10 minutes, you adjust the difficulty so that miners get to, again, spend 10 minutes for a new block. And just the whole Bitcoin Cash thing, you just make everything so much bigger, but you're not fixing anything. So that's why I still believe in Bitcoin, because the people that are working on some of the crazy things that you have to listen to 20 times in order to even barely grasp what they're trying to do. But I mean, none of us, even though there's probably a bunch of people that know how networking works and you can configure your own router and stuff like that, but do you know how it works, how BGP works or how OSPF works, and like how those crazy big protocols that make everything actually move? You don't really need to, but at the same time, that concept of putting a patch on something is just not what I want to believe in, because I'd rather look maybe 5-10 years into the future and know that this is going to be sustainable over a long period of time. So the whole blockchain being too big with Bitcoin, I don't think it's a problem yet. With Ethereum, soon to be, I would assume, just because I think it's a 300 or 400 gigabyte network right now, or blockchain.
So,
And it doesn't have a cap, so it's going to keep growing and growing and growing and growing, because you're going to have so much more money and so much more people eventually. Maybe, I don't know. Just kidding.
So are you looking at it more for as like transactions, or are you looking at it as a store of value, like?
So right now it's more